Hello everybody, we're getting ready to do lesson 7.3 for Algebra 2. This will be part 1 of 7.3. If you want part 2 and part 3, then email me here. 7.3, analyze geometric and sequences and series. We have a class worksheet of 34 points, and then we have a notebook sheet that's got 14 points worth of notes to take on it. Teachers, here's your bell work. Give your students about 5 minutes to complete this. Attach a sheet, students. If you don't have enough room to do all the work on this sheet, attach a sheet. If you're a homeschooler or if you're taking this online, take a picture of it and attach it to the rest of your sheet. Okay, welcome back everybody. Here are your solutions here. For number 1, we have our original problem here. This is the formula that we're going to use here. And then we get it into this form here, where we divide through by 2 on both sides. And then we plug in here from our values up here in our original statement. And then we come up with negative 3n squared plus 17n plus 56. And then we take we factor 2 binomials out as trinomial. And then we get this solution here, n equals 8 or n equals negative 7 over 3. The number of terms must be positive, so n would equal, here is your solution for number 1. And then for number 2, we have this as our original. This is the formula we're going to use here, n minus 4. And then a to the 5th plus a to the nth equals 455 times 2. We factor out our 2 here. Then we come up with this expression here after we do our multiplication. And then we factor out, wait a minute, and then we come up with this. We get this quadratic here, then we factor it yet again, and we get n equals 9 or n equals negative 67 over 6. Must be positive, so it's n equals 9 for number 2. Those are good problems. Answers. Okay, into our lesson. 7.3, analyze geometric sequences and series. You've studied arithmetic sequences and series. You will study geometric sequences and series, so you can solve problems about tournaments. In a geometric sequence, the ratio of any term to the previous term is constant. This constant ratio is called the common ratio and is R. So for example 1 here, identify a geometric sequence. Tell whether the sequence is geometric. We have, there's our sequence here. To decide whether a sequence is geometric, find the ratios of consecutive integers. So a2 over a1 equals 10 over 4 equals 5 over 2. And then a3 over a2, we have 18 over 10. That's 9 over 5. And then the next one, a4 over a3, would be 14 over 9. And then a5 over a4 would be 10 over 7. So the ratios are different. So the sequence is not geometric, Okay, what about this sequence here, B? We're going to decide whether it's geometric or not. So our first ratio, second ratio, third ratio, fourth ratio, they're all 1 over 5. So the sequence is geometric here. That's how you do it's geometric. Okay, now tell whether the sequence is geometric, explain why or why not. So we have 1/3 for that ratio there. This one's 1/3, and then this one is 1/3. 3 over 9. What about 1 over 3? 1 over 3. Series is geometric, a common ratio. Key concept here, rule for geometric sequence. The nth term of a geometric sequence, the first term A1, and common ratio R is given by this here. Here is our formula for figuring a geometric sequence, a to the first, r, n minus 1. First term is a1, and the common ratio is r. Example, the nth term of a geometric sequence with a first term of 3 and a common ratio 2 is given by here. So we have a first term of 3, this is a1, and then a common ratio is 2 is r, and then n minus 1 here. Write a rule for the nth term for this sequence here. The sequence is geometric with first term a to the 1 equals 4 and a common ratio r equals 20 over 4 is 5. So a rule for the nth term, we're told that this term is geometric right up front. So therefore we can use this formula here. Here's the general rule for a geometric sequence. So here's our plug-in, 4 times 5 to the n minus 1. 5 is our r, and 4 is our first member of that sequence. So the seventh term would be a to the 7th would be 4 times 5 to the 7 minus 1, which equals 62,500. Okay, example 2, write a rule for the nth term. Write a rule for the nth term and find a to the 7th. We have this sequence here. The sequence is geometric for first term a1, 152, and a common ratio of negative 66 over 152 equals negative 1/2. So a rule for the nth term would be a to the n equals a to the 1 r n minus 1. So 152 times negative 1/2 n minus 1, 152 for a1, and negative 1/2 for r. And we're trying to find the 7th participant in this sequence here. So when we do 152 times negative 1/2 to the 6th power, we get 19 over 8. You can use your calculator for that. Here's our guided practice. Write a rule for the nth term of the geometric sequence, then find a to the 7th. So we have another a to the 7th here. And then students, this one's on you. This is your independent practice here. Write a rule for the nth term, then find a to the 7th. Okay. So a to the 1 equals 1. R will be, we put this over here, negative 4 over 1, which equals negative 4 is our rate. So we can plug in now 1, which is our first term, times negative 4, which is our r, to the n minus 1. And we're trying to find the 7th member sequence. So negative 4 to the 6th power will be positive 4090. Write a rule for the given term. So we have a geometric sequence where a to the 4th equals 12. The common ratio is r equals 2. Write a rule for the nth term. Now we have to write a rule for the nth term. Use the general rule to find the first term. Here's our general rule. And then now we plug in the information that we have. A to the 4th would equal a to the 1 r to the 4 minus 1 here. These match here. These match here. So substitute 4 for n, and we know that 12 is a to the 4th. So we have a to the 1st times 2 to the 3rd power here. So we're trying to find a to the 1st. So 1.5 equals a to the 1st. Solve for a to the 1st. So a rule for the nth term is, it writes our general rule there. So we go 1.5 times 2 to the n minus 1. Substitute 1.5 and 2 for r. and then that will give us our sequence. Okay, a to the n, 1.5 times 2 to the n minus 1. Create a table of values for the sequence. The graph of the first 6 terms of the sequence is shown. Here's a table for this sequence here. And then the graph for this is right here. Here's our graph for this sequence here. Notice that the points lie on an exponential curve. So it is an exponential. This is because of this element up here. We have y equals ab to the x pretty much. Okay, so our guided practice here, writing rules. Students, you're going to write rules for this. So pay attention when we do this in class right now as our guided. Okay, write a rule for the nth term of the arithmetic sequence, and graph the first 6 terms of the sequence. We have a to the 1 is 5 and r is 3. So we're given a to the 1 and we're given r. So a to 1 is 5, r equals 3. So here's our plug-in here. 5 times 3 to the n minus 1. This would be our table for this sequence here. We have our rate and we have our a to the 1 there. And then that was our graph. Okay, for part 2, part 3, email me here. For worksheets, email me. Thank you.